So we are here at last after hearing the whole day about different IoT, sensors, enterprise, consumer side of IoT, to talk about what's coming in the future. So for that, we have three great panelists here. And before I start the introduction, just want to talk a little bit about the format. So I'm going to ask a few questions to this gentleman, and then I would really like you to participate in this discussion because it's about future, so I'm sure you all have some ideas and questions. So there's a mic here at the center in the front. So when I ask questions from the audience, please come up to the mic and give a tough time to these guys. So that'll be fun.
Make us think.
Yes. So with that, I have Kevin Short here to my right, Amit Narayan, Guido Jouret, and then Amit Narayan. And I will let them introduce themselves with a short few sentences, and then we'll start the panel.
My name is Kevin Shaw. I'm Chief Technology Officer at Sensor Platforms. We're a local venture-backed startup, about 10 years old, and we specialize in sensor software for mobile devices, sensor hubs, wearables, and IoT devices. There's remarkable similarity between all of those because in many cases you have sensors connected to a core with some software to wrap it all up and some transport mechanism. We specialize in the, say, for example, sensor fusion software, which merges it together, contextual awareness software, which runs in the background, always on, to understand you, your lifestyle, your contextual environment, and also pedestrian navigation capability. But if I may also jump in, just on Monday this week, we did a major announcement in conjunction with ARM, where we open sourced our entire sensor interface framework. This is just came up on GitHub. It's a C source that allows an embedded environment, say a wearable or an IoT device, to quickly come up with sensor drivers, algorithms, interface over a PHY to an application processor. Everything needed basically in one repository to bring up an IoT device. This is being very positively reviewed by the major silicon providers. We think this is going to make it dramatically easier for wearables and IoT devices to be innovative and come up with new great ideas.
I'm Guido Jouret, and I look after the Internet of Things for Cisco. So Cisco essentially doesn't make the devices or the applications for Internet of Things, but we're the connective tissue. So we make ruggedized switching, routing, wireless access points to connect all of these things. We've been in this market for a couple of years, and we have created solutions for oil and gas, for utilities, basically the B2B marketplace.
Hi, my name is Amit Narayan, and I'm founder and CEO of AutoGrid. At AutoGrid, we are building software applications for the electric utilities and their customers so that they can optimize their operations to reduce cost, while at the same time, the overall system can become more sustainable, more reliable, and more efficient. And so one of the key issues in the electricity supply chain is that it's the ultimate just-in-time supply chain where there is very little storage. And even though it's really amazing that the system works, it is incredibly inefficient. There are about $400 billion of capital infrastructure that has to be maintained just to serve those few 2% of the hours where the electricity usage might be the highest. And so using our software, electrical utilities can offer programs to their end customers where if they shift their usage, they can save money or even make money while the overall cost of serving them goes down dramatically, which also helps other customers who may not be even participating in those programs.
Okay, thank you, gentlemen. So I was driving this morning to come here, and I was listening to one of the radio shows. Someone talked about a Confucius saying that to know the future, you need to understand the past and the present. So with that, let me ask you guys this question about IoT. You know, IoT has been around for a long time. So what has significantly changed now that a lot of people tout this as the next big thing? So who wants to go first?
Well, I'm happy to jump in on that one. I have a MEMS background and a sensor silicon background. I think someone much wiser than me made the statement that this is a peace dividend of the smartphone wars. that the many years of smartphone wars with cheaper, better, faster smartphones, they've matured, but they left us with a peace dividend, a legacy of these amazingly cheap, low-power pieces of silicon. A great example are some of the sensors on them. For example, a MEMS accelerometer, three-dimensional, three-axis device, digital, 30 cents now. It's about 1.2 millimeters by 1.5. Takes a couple of microamps to run. You can run that for months on a lithium battery. This is what we're left with, is this amazing silicon already available in high volume. Suddenly people are asking, well, I'm already selling 1 billion smartphones a year. Can I do anything else? And so I've got cheap silicon available just waiting, and we don't even have to redesign it. So I think there's huge opportunities just because we have amazing capacity just waiting for something to do with it.
Great.
I think those are great points, and certainly the availability of cheap hardware and then open source software is driving a lot of the availability or supply side. I think on the demand side, Prakash, I think the fundamental difference or the fundamental reason why now is that the world is facing some severe challenges. If you think about, for example, we're going to need 40% more energy by 2030. Half of all the water that is processed is lost in transit, right, before it actually gets to your faucet because of leaky pipes, leaky infrastructure. The planet is heading to 9 billion people. We need 50% more food. We're not going to find 50% more arable land. But the reality is that half the food that is actually grown is wasted before it actually gets into your mouth, right? You either throw it away or it rots or something else. So there's solutions, I think, to be had in terms of making a lot of these processes more efficient, and we have to tackle them. So on the one hand, as Kevin said, there's a supply, but there's also a demand. There's a demand of like urgent, pressing problems that I think communication, information, connectedness can solve.
Great. Amit?
Yeah, and just to build on Guido's point, I totally agree with what he said. In our industry, we have seen 2 generations of companies already in the Internet of Things space. The first are the companies that are building meters and sensors that are able to collect the data and bring it to the utility company or to a service provider or to the consumer. And then there have been companies that have been built to manage that data or store that data. But the situation today is that this data, depending on which sensor it is coming from, is still sitting in a very specialized data store. And it's very hard to build applications that can leverage data across many such systems or many such sensors. And so from my perspective, the next wave, at least in the electricity grid that I see, is around how do you create platforms and infrastructure that allow us to build these applications much more cost effectively and much faster than was possible before. And in particular, these applications will not just analyze the data and generate some reports, but they will also be able to predict what's going to happen in the future and take some actions around optimizing that future, and then be able to change the state of the sensor from which, or the device from which this data is coming in, thereby sort of closing the loop. And so I call this dynamic closed loop optimization, which is now becoming possible with big data techniques and other cloud-based software solutions.
Great. So the sensors are getting cheaper, there's demand, and there's a huge problem to solve.
Yes.
And we have very talented and hungry entrepreneurs in the audience. So looks like it's a perfect storm to me. So
Yeah.
now that we've come to that conclusion, take out your crystal ball. And if you haven't brought one, just peer into a virtual one.
I'll look into this.
And tell me, what do you see is going to shake up the IoT market in the near future, so that some of these guys can go home and start working tonight?
I think the beautiful thing is there's a lot of different layers at which you can focus, right? So Kevin was talking about this, the MEMS and the sensors, but frankly, let's sort of decompose the problem. I call this sort of the Maslow hierarchy of IoT. You've got, connectivity, right? Solve the connectivity problem. Lots of things that aren't yet connected. They're hard to connect, right? So inside of a mine, on an oil rig, outside. I was just talking to a utility customer this morning, and most of their region isn't covered with 3G. They're up in the Pacific Northwest. So they need another technology. So that's one area. Second is data. So to Amit's point, you're going to generate a lot of data. That's nice. You need to store it. Number 3, you need to take the data and refine it, because a lot of the data is raw data. It's just measuring temperature, vibration, things over time. That doesn't actually mean much unless you distill it into some patterns. And then once you have those patterns, could you use some of those patterns to actually predict what's going to happen, and then you can do automation. So that's the world of analytics and automation and control systems. So you kind of can take your pick. I mean, that's one of the beauties of this whole market is there's so many places where innovation is happening simultaneously, and they all need to come together.
Amit?
No, I think, again, fully agree with Guido here. I think there is innovation happening across the food chain, and there are two types of companies that I see. One are horizontal companies that are providing infrastructure solutions, which are broadly applicable across industries. And then there are companies like ourselves and others who are focused on a vertical. And there are some significant challenges, last mile challenges that have to be solved in specific application domains around how the system works and how those inefficiencies might be. For example, a simple use case in our industry is world over, significant amount of electricity is stolen or lost in the supply chain. In fact, electricity is the third largest stolen commodity in the United States after credit cards and automobiles. And so there is clearly a huge opportunity in using the sensor network to see where that loss is happening and trying to recover that. And the applications and algorithms that will be needed for something like this will be somewhat domain specific, and that's where companies like ourselves can make a contribution.
Kevin, anything to add there?
Yeah, I think what's interesting is that as the cost of these devices, I mean, it used to be hundreds of thousands of dollars for devices. Now, as you have devices that are so small, with the sensors so small and batteries, we can put them everywhere. It's no longer a question of, first of all, having to connect it to a power line. Some of these devices are so small, so low in power, I can put it on a lithium battery and have it run for 6 months, 12 months, a couple of years if I put a couple of lithiums on there. So now the question is, how many places can I put it? And with that, the possibilities just explode. It's not just everywhere there's a power line. Now it's any place where I can imagine needing it, whether that's even on my body. You know, I've got a wearable on my wrist here that lasts for 6 months. So now I can put it or on the wall or sensors in the car and whatnot. So once they become this small, then the question is, well, if I want it to last that long, I need to be able to minimize how much power or how much data I send so I can keep the battery a long time. So these are the interesting challenges. You know, they're going to go everywhere. I love one of the statistics, and I think it came out of Cisco, where they were saying, you know, we're now at 2 to 3 connected devices for every man, woman, and child on the planet. That's a lot. But that's nothing like what we're going to have at the end of the decade, where it's going to be 10 devices for every man, woman, and child on the planet. You know, let's take that roughly at 8 billion people. That's 80 billion devices. And I don't think we're stopping there. So how do we integrate all that? How do we sense it? How do we keep it so we don't have to constantly change batteries? There's lots of interesting things.
Great. So I only had to worry about my car keys now when I get out of the house. Now I have to worry about these 10 devices dangling from my body. Great. Okay, so
Devices will worry about you.
Some of them will be implanted in your body as well.
there you go. So that I don't have to worry about not taking. So at least that's good. So in the meanwhile, if you guys have questions, please come to the front here, the middle, in front of the mic, and I will, in the meanwhile, ask another question to the gentleman. So, you know, one way to look at it is whether it's half full or half empty. A lot of people claim there are still some major blockers for IoT to become pervasive and the adoption curve to really go up. So what do you guys see from what you've been working both in the silicon space and the device space and the enterprise space as some of the blockers that needs to be removed? Anybody?
Well, I mean, for us, it's a pretty easy answer, actually, given that we are in the industry which is pretty highly regulated. And so one of the barriers that we face are just policy decisions around data privacy, security, as well as the investments that need to be made in this industry. And so from a technical perspective, I mean, clearly there are challenges, but that's not necessarily the number one sort of barrier for the industry that we operate in. It's more around giving comfort to people that this is valuable, tangible value is getting created, and therefore it's worthwhile to open up some of the data sources and make the investments that are needed to make the system more efficient.
I see a main barrier, and I overheard a little bit of the previous panel talking about privacy, but privacy on the consumer-facing side, security on the business side. So when people wire up all these connected devices across common, converged, standard-based networks, their key question goes to like, look, if my car drives itself and my solar farm is being managed by the software, if my grid is self-stabilizing, what about hackers? What about Stuxnet? What about things like that? There could be a real risk because we now become very dependent upon software and connectivity, and once you're in, you could potentially go everywhere. So I think the security angle is a real key, and I don't think it's a unsolvable problem, but historically the challenge has been that the industrial side of things, I mean, here's an interesting statistic, 95% of the ATM machines in the United States are still running Windows XP. So this is not, the industrial side is not the most up-to-date when it comes to technology. So that is a risk, and that is probably a bottleneck or at least a thing that's going to hold it back unless that gets addressed.
Sure. Kevin?
I mean, for me, well, as long as you have a hammer, everything looks like a nail. So for me, my nail is software. We've got sensors everywhere, and the old mindset was, well, if I got a sensor, I'll stream the data up to the, something big, and I'll compute it there. Well, for us in the IoT world, very often transporting that data wirelessly is the most power-expensive thing I can do. So if I can minimize the data that I send, then I can really reduce and extend the battery life. So software that can identify what's going on and only find something interesting, whatever that interesting might be, becomes very critical to allowing devices to sit quietly, understand what's going on, and only tell you when something useful is going on. So I think intelligent creative software, and there's a lot of people in this room that will come up with it, that is going to be very interesting here.
Great. Good. So I think there's somebody ready with a question here.
So thank you for the wonderful insights. I did hear a lot of comments which were also pretty amazing about the shortage of food supplies and electricity and things of that nature. I didn't know electricity was the third most stolen commodity, if you will. So along those lines, one of the fundamental beliefs that I have is whenever there is a business reason that corporates have, along the way, they definitely make business happen, but also there is good things that also happen. So when we look at continents like Africa, less than half of it actually receives electricity where they need to. And that has become a showstopper for their education, for their prosperity, and so many other building blocks. And as we touched upon these topics of bringing electricity or saving electricity, maybe passing it on to the folks who need it, what business reasons would an area like IoT have, which would then further help drive some of these areas to receive electricity? Because I don't think the other way around is going to be possible. So would love to hear your perspectives.
I love this question. So in particular, I think one of the powers of Internet of Things, and Shailesh from Cisco was just telling me that, for example, Maker Faire is happening tomorrow. One of the things that I think IoT enables is 200 years ago, everything was local, right? Your family would live on a farm, they would grow their food, they would have a well for water, their energy was from the wood they had chopped down. So everything was within a very small radius of where you lived, and it was highly sustainable. Sure. Then what happened in the industrialization of the world is that the Western world went to models whereby, your oranges are coming from Florida, your bottled water is coming from Italy, right? And we're shipping things over long distances. And the problem is that's very intensive in terms of energy demand, and we need highly centralized infrastructures to do it. I think the promise of Internet of Things is that we can kind of go back to being local, but with the efficiency that we have with a centralized or more sort of globally centralized model. And that's everything from like 3D printing, making manufacturing small, to local electricity generation from wind and solar, if not to your house, at least to your village or town. And I think the promise of IoT is that, the reason why a small local village went to that model was that drinking the water from your well was a risky proposition. I mean, you might get Legionnaire's disease, you might have malaria. I mean, it wasn't necessarily the safest thing, whereas your tap water is very safe, very clean. But I think here we can have our cake and eat it too. And I think for the emerging worlds, this is interesting because they don't have to go to that centralized model. They can go right to a more decentralized world again.
That's very interesting. Any of the other panelists want to jump into that? No?
Makes me think of the book by Peter Diamandis on abundance, which is a wonderful discussion of some of these topics about how bringing stuff local, how having your own water purifier per village really changes things, and it really doesn't take much to make a dramatic improvement to a couple billion people.
Hi, thanks for the insightful discussion. You guys talked a lot about how sensors will come together, create data, and then the data will further get disseminated. How will all this explosion of data change the way we interact with our day-to-day machines? In particular, I'm interested in understanding and knowing your business insights more about how, since the Stone Age, I would type and I would move mouse. Now I have stylus. Now, where are we headed with this explosion of data? Like, are we going to be able to talk to machines all the time? Is my city, which needs connectivity to cloud, going to be functional to that level where all these connected devices are more effective? Or, what kind of new modalities will come and what would be their business potential?
All right, gentlemen, take out your crystal ball again.
Oh, that's one of my favorite topics. That's like a softball pitch. So for me, this topic, I love quoting Mark Weiser, who was CTO of Xerox PARC back in the early 90s, and he wrote some wonderful words. Basically, the whole point here is for technology to weave its way into the very fabric of our life to the point where we no longer see it. The old idea where I would go to a desk, sit at a keyboard, and type, I'm effectively learning its language. Now on the flip side, we have devices, I don't do anything special for this. I just put it on. It interprets me. So I think the whole point is that these devices need to understand us, and we almost forget about them. At the point I have 10 devices around me, say 50, make it 100. I've only got 1 unit of attention, so I've got 100th of the attention to give to each of them. So for these to get to that level, they must actually vanish to us. They must almost become imperceptible with almost no interface, in which case if they do interface, it should be on our own terms. I like to talk to things, or better yet, it should just know. And that's where this becomes almost a non-interface. I'm just living my life and it's identifying what I need next. So I think this becomes a very interesting world just with these natural interfaces.
The Siri has to get a lot more smarter then.
Yes.
Yes,
Okay.
yes.
It seems to me that I guess we've started to see, or we've seen fundamentally new business models within the transportation sector: connected parking, dynamic congestion pricing, Zipcar, Uber. I mean, so both around hardware, around smartphones, even pay-per-mile car insurance. So some really exciting, fundamentally new business models within, on the infrastructure side, within industry. It seems like much of the vast majority of the substance of our conversation is about asset monitoring, kind of amelioration of existing business models and processes. And I'm just curious whether you guys have begun to see kind of fundamentally new business models on the back of sensor ubiquity in spaces apart from or beyond transportation.
Yeah, so I'll provide one, and I do think that's really interesting. It's almost like, on the one hand, when you connect something, the maker of that thing can now provide it as a service. So there's like a first order benefit. But then the second order benefit is like when you connect that device, you're getting all this interesting data. So I'll give sort of 2 examples. Within the next couple of years, most cars on the road are going to get connected. So now imagine you're Ford Motor Company and you put dozens and dozens of sensors into this car. You now are collecting all this information, like how fast people drive, where they drive, potentially where the potholes are because they sense the dampening of the shock absorber. They also now, interestingly, have information on the reliability of the Michelin tires versus the Firestone tires or the Bridgestone tires. They also then can take all that information, and it's interesting enough, what they call cars actually become a source of interesting data which suitably anonymized to respect people's privacy. They could actually potentially sell back to the very suppliers that are selling them those components. So I like to say that in the future, every company is going to become a service provider, and every company is going to become Nielsen, which is they're all going to get all this data that they can potentially monetize and turn into a revenue stream. And then there's certain companies that are going to just purely live off of this, call it data exhaust that's coming off these processes, and they'll do a better job analyzing this data than you can. And my favorite little example of that outside of transportation is a small Israeli company called Takadu. It's kind of a strange name, Takadu, and full disclosure, I'm not a shareholder, but they actually analyze sensor data coming from water utilities, and they don't even go to visit. They just say, plug in some sensors into your pipes, upload the data to our website, and our smart software is going to tell you where the leaks are. It's a pure as-a-service model that analyzes this, and the most amazing thing is those people that work for Takadu have never worked for a water utility. In fact, they just hired a bunch of smart PhDs in math. They look at it as a graph problem.
So we see the smart sensors, smart like big data and cloud. So these three things come into picture, but one piece, I want to ask the question about the future of the data security. Is this device going to talk to this service, and this service is only going to give the data to this particular service provider? And how secure will the data be? And what is the future of the data security going to be in next few years?
I'm not necessarily the biggest expert on security, but clearly it's a big concern in our industry, specifically the electric utility industry. And there is a huge amount of innovation which is happening in this space, in this whole cybersecurity world. And I mean, for example, in our case, we are one of the issues is that you can make the network very secure, but the cost of doing this could be prohibitive. So for example, there are certain programs that California ISO, the system operator, offers, where if you are connecting some sort of a device to their system, you have to go on a private ECN network, which is outside of the public internet. And the cost of doing that, after you account for getting a lease line, could run into hundreds of thousands of dollars, which means that only very, very large customers are able to access these services or monetize the opportunities that are out there in these markets. Now, using the modern security infrastructure, some of the protocols that are coming in, ways of sort of blacking out your network on a public internet so that you don't have to expose your IP addresses and DNS servers, you can bring that cost down to hundreds of dollars instead of hundreds of thousands of dollars, which means that you and I, as regular home users, can take advantage of some of these opportunities that are out there, which again, it's a pyramid. So as you are able to get more users into the system, you are overall making a bigger contribution to the supply chain, and so and bringing the cost down for everybody else. And so that's I mean, so security is going to obviously play a huge role in bringing the cost down, but specific technologies are probably something that Guido can comment on.
Yeah, I think one of the challenges is, to Kevin's point, when there's so many sensors around you, and you may not even be aware of them, surveillance cameras and other things, they don't exactly come with like an end-user license agreement pasted to the front that you can then say, yes, I accept. I mean, so we're going to get a lot of data getting absorbed. So part of it is actually going to be, we are going to live in a world of diminished privacy. That's just a fact. The second part, though, I think companies can do a lot better by creating what I would call a sort of customer bill of rights, if you will, when it comes to IoT, which is what do you do with people's data? And there's like best practices. I think you can anonymize the data, encrypt the data at rest, encrypt the data at motion. So I think there's a bunch of things you can do that would actually help make the world safer for IoT. We don't have to have laws for that. We can do that ourselves.
Great. Okay, so in the interest of time, we have 2 minutes left, so I'm going to go into a different format now. So any of you have seen the John McLaughlin's show, he asks his rapid fire questions. So I'm going to ask rapid fire to each one of you, 1 word or 2 words. So Amit, you start. Apple, Intel, Google, Microsoft, Cisco. Who will win the IoT as a dominant player?
None of them.
Leading the witness, I think all of them will have a
2 words.
role. All.
Apple.
Okay, IoT will be bigger than internet in its impact in the next decade. Yes, no? Kevin?
Yes.
Get it?
Yes.
Absolutely.
Will increase in minimum wages affect growth in IoT? Yes, no? Amit?
Don't know.
Sorry, I didn't answer that question.
Increase in minimum wages affect growth of IoT?
Maybe.
That's a curveball.
Yeah, that's a tough one. I'm not an economist.
Okay. Thank you very much. So please give a big round of applause to the panelists, and I hope you guys got some insight.